Welcome back, everybody. This is lesson 7.2 notes. We're going to try to go through this pretty quickly today because there's a lot to do and I want to try to get it done so it's a reasonably short video. So we'll get going here. The warm-up questions for today. Remember, when you're finding unit rate, you want to try to find 1 on the bottom, so you divide the top by the bottom. So we take 192 divided by 6 and we get 32 times per minute. The next one, in your notes, I think it had this switched around. It said 4 pounds of bananas for 236. I want to switch it around and say 236 for 4 pounds of bananas. So we do 236 divided by 4. That ends up being 59 cents per pound. All right, and this one here, explain the difference between a ratio and a rate. Ratios, remember, do not have to have a denominator of 1. They can be, 3/2, 3:2. With the rates, they have to have units. They have to have, labels. That's kind of like our word problem. So we have to have like gallons per minute, miles per gallon, miles per hour, those kind of things. Describe why you think it's helpful. Supermarkets to include unit price as well. It helps the consumer, the people that are buying the food, to be able to say, hey, which is the better deal? Am I getting a better deal by buying this larger size or by the smaller size? And especially if you go to places like Walmart, you'll see the little orange tag in the corner that says like 2.1 cents. That's talking about 2.1 cents per ounce or 19.4 cents per ounce. So you can compare to see which one is the better buy. All right. Today we're going to focus on proportions. And in our notes, we're going to write down the definition. So proportions are equations that state that 2 ratios are equivalent. And we talked about ratios yesterday, so writing down 2 ratios that are equivalent, and then we're going to put an equal sign in between them to show that they are equivalent. With cross products, if you have the proportion A divided by B, or A to B equals C to D, then they have cross products of AD and BC. So you cross product, you go diagonally across the equal sign, A times D and C times B, and those 2 values will be equal. All right, so there is the rest of the notes for that page, and you guys have these copied down in your notes. This right here is super important. Cross products of a proportion are equal, and that is going to allow us to set these up as equations today in order for us to be able to solve them. Okay. The next thing on your notes, real quick, we'll get through the vocabulary, then we'll go do some examples. Scale model. The dimensions of a scale model are proportional to the dimensions of the actual object. So if you've seen like a scale car, maybe you've seen like a little Matchbox car, they are supposed to be to scale, like 1 to 64. 1 inch would equal 64 inches on a real car. Or 1 inch would equal 64 feet, 1 inch would equal 64 miles. Same thing happened like on a map. You've seen these things on maps. So we're doing scale models. If you've seen a globe, they have a scale on them. And that scale is the ratio that actually compares the dimensions of the model to the real object. So you'd have the model, the little tiny thing, and you'd have the real object. And we're going to look at a couple of those examples in our notes today. Okay, we're going to go ahead and do some examples now. This is the first example that's at the bottom of the first page of your notes. It says, on Tuesday you paid $7.47 to rent movies. On Friday you rent 5 movies for a total of $12.45. Each movie costs the same amount to rent. How many movies did you rent on Tuesday? Well, we're going to use a table to set up these proportions. And when we set these tables up, you're just going to fill in the information that you know, organize it, get it nice. It says here in example 1, the ratios in the proportion use the following units: dollars and dollars, numbers of movies, numbers of movies. So we're going to keep our things lined up the same. Here I have dollars, they're in the same column. Here I have number, they're lined up in the same column. So I'm going to take that table that I made and turn it into a proportion. And I'm just going to take my number, I'm just going to actually copy my table down as a proportion. So 747 goes here on top, 12.45 goes here on bottom, and then X goes on top, and 5 goes here. Now it says use cross products to solve the proportion. So I would do that. I would take 7.47 times 5 is going to equal 12.45 times X. And I actually would do the work on this, and I end up with 37 35 equals 12.45x. Divide by 12.45. Divide by 12.45. And my answer becomes 3. I rented 3 movies, so 3 equals x. I rented 3 movies on Tuesday. So this will work for this way, where we set up the money up and down, and we did our Tuesday across the rows. And we can also do that another way, and we're going to do that on this next page. So there's other ways to set up the proportion. This table is the way that we originally did it. We can also set it up where we do Tuesday and Friday. And here we could put in the cost, and here we could put in the number of movies. Do the exact same thing. On Tuesday it cost $7.47. On Friday it cost $12.45. On Tuesday we don't know how many movies we bought. On Friday we bought 5 movies. So I set up another table, and this exact same table, I'm using the same information. I'm going to solve it the same way. Set up my proportion. 7.47 over x equals 12.45 over 5. And I would solve it with cross products just like I did the last one. 7.47 times 5 equals 12.45 times x. And I'm going to get the exact same answer. 37.35 equals 12.45x. Divide by 12.45. Divide by 12.45. 3 equals x. So I can set it up as long as I'm comparing the same thing. Here I had cost on top, number on bottom. So over on the other side I had cost on top, number on bottom. And you have to match up the data that you have. Friday, so Friday would be in this column, Tuesday in this column. If we did it the other way, we did Tuesday in this row, Friday in this row. So as long as you set up things where they match, you will be fine on these tables. Okay. Here's some examples that you'll see on your homework. These are just very simple solving proportions. Now the cool thing about these is there's 2 ways to do them. There's an easy way, if you can see patterns. And then there's the little bit longer way. It's not too hard, but it's the cross products. So with this one, I can see a pattern. I know that for me, how did I get from 2/3 to a over 15? Well, I know that 3 times 5 is 15. So I do the bottom, I do the top. I know that 2 times 5 is 10. So A in this example is going to be 10. If I can see that pattern, if I can find how I went from 3 to 15, I'm going to use that, and that's going to be the easy way to do these problems. If you can't see it, you would have to do cross products, and we can get the same answer using cross products. 15 times 2, because they're across from each other, equals 3 times A. Well, 30 equals 3A. Divide by 3. Divide by 3. 10 equals A. Notice I got the same answer using finding the patterns, and I also found the same answer using this. All right, over here on this one. Right now, I can't see any patterns, but if I reduce this to a simpler form, I can see some patterns. I know that both of these numbers are divisible by 4. So if I divide this by 4, I get 7. Divide this by 4, I get 4. So 7/4 equals m over 24. That's going to make my life a little easier. Now I can see a pattern, because I know that 4 times 6 is 24. So 7 times 6 is going to be 42. And 42 equals m. Same thing, I could do cross products and divide. That would give me the same answer. Over here, major problems. I don't see any patterns here at all, but I can reduce this. I can reduce these by 9, because 4 plus 5 is 9, so I know that's divisible by 9. 1 plus 1 plus 7 is 9, so I know that's divisible by 9. When I do that, I end up with 15. Well, not even 15. I can go even further down. 5 over 13 equals x over 52. Oh no, my pen stopped working. Let's go back. X over 52. Now, some of us can see this pattern here. I know that 13 times 4 is 52, and 5 times 4 is 20. But if I couldn't see that pattern, I know that I could figure it out using cross products. Now we're getting to the 10-minute mark, so we're going to try to rush through a little bit to our next couple examples. With this one, we have to use cross products. There's no way to really make this one easy. So to do cross products, I multiply 22.1 times 41.6, and that ends up giving me 919.36 equals, and then I take 10.4 times n. 10.4 n. Divide by 10.4, divide by 10.4, and n is going to equal 88.4. So using cross products, yeah, it's a little bit tougher, but I'm going to let you guys use a calculator, so that'll make your life a little bit easier, so you can do that math in the calculator. But I still want you to show me what numbers you got when you plug them in. All right, moving on. I know this is going quick, but we're going to move on to some tougher ones. Here it says solve the proportion, then check your solution. Well, we're going to, on this one, I'm going to use a simple, easy method. 5 times 4 is 20, so t times 4 has to be 32. What number times 4 is 32? 8. So t equals 8. Now, if I want to check this, I could do cross products. 5 times 32 has to equal 8 times 20. Well, 5 times 32 is 160. 8 times 20 is 160. So those worked out. I checked it right there. You're not going to check a lot of them on your homework, but there will be a few. This one here, once again, an easy one. 15 times 6 is 90. So 7 times 6, 42. And then I could check it the same way. All right, I would plug 7 times 90 equals 15 times 42. 630 equals 630. And you could use the calculator to check these. All right, I'm going to skip this one for right now because I want to focus on this. I know my time's getting short, so I want to focus on this one here. If I see a problem like this where I have an x on the bottom and it's x plus 2, man, that looks difficult. Not too bad. Do cross products. 2 times 27 is 54 equals 18. Now, this is where the distributive property comes in. 18 times x plus 2. And I would actually do that. 54 equals 18x plus 36. And then I would do minus 36 from both sides. 18 equals 18x divided by 18. 1 equals x. And then I could just plug that 1 in. So I would know that 1 would be my answer for that problem. Same thing over here, but I'm going to skip it for now because I want to make sure that I talk about scale. We need to do an example about scale before the video's over. So here is an example that talks about using scale. It says you use a scale of 3 inches to 50 feet. Well, if I wrote that down as a ratio, 3 inches to 50 feet. All right. Now, it says the height of the building is 316 feet. Find the height of the model. Well, when I do this, I want to set up my inches on top, feet on bottom. So I need the inches on top, and I need feet on bottom so that they match. Inches, inches, feet, feet. Now, what do they tell me in the problem? They tell me that it's 316 feet. So I fill that in. What they want to know is what is the height of the model, and the height of the model is going to be in inches. So I'm going to give that my variable. That's going to be x. And I can solve this the same way. 316 times 3 is 948 equals 50x. Divide by 50. Divide by 50. My answer ends up being 18.96 equals x. So that'd be 18.96 inches tall. That would be my answer on that one. And I notice my time is getting down to about 45 seconds is all that we have left. One major important thing here, make sure that you do inches match with inches, feet match with feet. I could do 3 inches over x inches matches with 50 feet over 316 feet. I'd still get the same answer because I'm still going to multiply across here, multiply across here. That's just another way of doing it. Your assignment for today is page 350, 2 through 32 even, 39 through 41, 44, show work if necessary. All right, we'll see you later. Have a good day.